Okay, Lady Ada, what is this?
It's time for show and tell. That's a song that we sing here in time for show and tell. No,
Adafruit the musical coming
It's true. I wish I was a singer, but it's not. It's time for show and tell. It's me, Lady Ada. With me is Mr. Lady Ada, and behind us is the Adafruit factory. We design, test, ship, manufacture all the electronic goodies you know and love. We've got show and tell, our favorite, almost half an hour of the week, where we get to see what people from around the world are doing, including some Adafruit folks who love to show you behind the scenes what's happening in their homes and workshops. So let's kick it off with some Adafruit folks, and we'll get to other people's. Let's start off with Scott.
Hello. This week I have a keyboard to show, as always.
Keyboards?
Keyboard, well, yeah, I suppose. Two halves of one.
Keyboards. Yeah.
This is the one.
Okay.
Not hit my mic. It's called a Keyboardio, and it's supposed to be really hacker friendly. And it's nice because you can split it. And the stands that have it are not straight. So depending on how you angle it on the stands themselves, you get different tenting is what it's called. And I'm very excited about doing that because what I'm finding is my current keyboard, when I rest my hand, it's down below and causes my wrist to be crooked. But if I can tent it so that my hands, like the palm rest is higher than the keys itself, I'm hoping that will make my hands happier. And this has also got me thinking about the idea of, like, if I want to redo one of these circuit boards so I can run CircuitPython on it, how do I do it in a way that when we come out with some, like, even cooler microcontroller hardware stuff, that I can just, like, pop in a new module and get the new stuff rather than having to spin a full board that has all the keys on it. So I've been brainstorming some ideas on how to make that happen, specifically looking at M2 connectors.
What's an M2 connector?
It's like for like a SSD. Like you slot it in and then you screw down the other side to get it to sit in there.
Yeah.
They're like, $1-ish on DigiKey and singles. So that's, it's like super popular, just like RAM connectors. Like I looked at how the Raspberry Pi does it with their SODIMM stuff, and it's similar idea.
All right, cool.
But yeah, so I'm thinking about that. Although I'm actually trying to do partial screen updating, so hopefully by the end of the week I'll have that going as well. Won't be trying the new keyboard until I do.
All right, sweet. Thanks for the update. People love hacking keyboards and displays. All right, next up.
Yeah, they got really cool stuff. I'm excited to try it.
Yes, more keyboards. Never enough. Phil B, what is going on with your Pixel geniusing?
Hi, we have been, but at the moment, I've been like really nerding out over the TI Speak and Spell from the late 70s, early 80s. This is a goofy educational toy I think we all had. And there is a library for Arduino called Talkie, and it simulates a different speech chip that was used in the TI-9948. It's slightly different, and I had to make some tweaks to it, but I was able to get it to replicate the original Speak and Spell voice. And the reason I'm nerding out over it is that each of these speech synthesizers had its own accent. Like there was the Radio Shack chip and the TI-99 and the Speak and Spell and SAM and Amiga and stuff. They're not interchangeable. And, if you want something to sound like a specific nostalgic device, you really have to emulate that device. It's not right. It's like Kermit's voice. When someone takes over the character, kids know that's not really the right voice. So anyway, I made tweaks to the Talkie library so that it's actually speaking like Speak and Spell language now.
Now spell mosquito. That is correct.
So this is coming out of a Pygamer rather than the Speak and Spell. But there's a particular accent to it, and so I was just really nerding out about getting that going. And it's neat. I could talk about it for hours because there's just funny trivia about the thing. It's not phoneme based, and it's not really sampling. It's using a type of synthesis called linear predictive coding, and they actually had this suitcase computer that they would roll around to a studio or an office. And so when the Speak and Spell talks. That's a specific dude. That is like one guy that sat there and said all those, and then it's like this super lossy compression that you're hearing, and that's why you can't get a speak and spell to just say anything. You have to have these little snippets out of ROM that were recorded 1,000 years ago in this TI office. One of the words I'm playing back though, mosquito, that was never in the speak and spell dictionary that you have to spell. That I found like an orphaned word off in the ROM that ended up not being used.
Oh, so you're like actually uncovering like the hidden mysteries of the speak and spell.
Yes, exactly. Also, because of the way audio is encoded, a pitch is a separate variable. Like I said, it's not really sampling, and you can actually tweak
Now spell
the sound, the voice coming out of it, the pitch.
mosquito. Now spell mosquito.
So you can adjust the pitch independent of the speed. I think it's really cool just because I'm a nerd. I don't know that it has practical applications, but I'm excited about it.
This is the best History Channel show I've seen in a long time.
I know.
This is way better than Ancient Aliens.
Here is your score.
This is neat because what would be cool is to have maybe a blog post or something if you're willing to do it, dialects of the speech synthesis, because it's, like there's a Southern accent, there's like a Boston accent. It'd be neat to like which accent is from what chip or something like that.
Yeah, like I said, it's
so specific to the manufacturer.
The speak and spell, or that line of speech chips, unique was you had inflections and accents and stuff, unlike Sam or others, which were just a monotone, because this was actually a person speaking, essentially. It picked up this nuance. I mean, it kind of trashed the nuance, but there's a distinctive tone to each product using those speech chips.
That is correct.
Yeah. That's just nice to have around at all times. It's like whatever you say, it's like that's correct. Like,
yeah.
I like this. So you can still soundboard for me.
Yeah, I'll do a soundboard because there's dozens of words in there. I'll make something for one of our boards, maybe the Pi portal, that you can just play back some of these things and relive the that voice that I think a lot of us know, and we want to hear that voice.
yeah.
Okay.
All
With
right.
the comforting voice of your robotic mother. All right, Noe and Pedro, what are you 3D printing today?
Hey folks,
Hey, guys.
I would suggest the Neo Trellis because I like the squishiness of the elastomers. It's fun.
Yeah.
Cool. Yeah. So we've been experimenting and playing around with print in place hinges, particularly for making a crank for these rotary encoders. We got these little rotary encoders. These are really fun. Where's my camera? Is that it? Okay, there it is. So
Yeah.
these guys have little knobs, and so we made a little accessory so you could turn a boring old rotary encoder into a very fun and hip new crank. So this is a one single piece that has this sort of hinge inside of there. So it prints flat on the bed. It doesn't require any support material to 3D print. And you get this this sort of double articulating piece here. And then this sort of handle also swivels. And none of these parts can be disassembled, so you can't take them apart. And they are printed as is, so there's no assembly required. Yeah, so we are playing around with different enclosure ideas to kind of make this so that it hides in the thing. Oh, I just popped it out. That's great. That's fun because it is supposed to come out. So the flat edge kind of fits in there, and then you can do sort of this number here, and then it hides into itself like that. You can still click it because it has that click in there. Cool. So we're thinking about making this into its own kind of USB head device so that we can plug it into any old computer and kind of have our little crank accessory so we can, I don't know, turn up the brightness or something else.
Good for rolling terms of service.
Sure, that's a pretty fun idea. I think I like that. So we might be able to do that with one of these guys, a little Trinket M0 running CircuitPython,
which is actually inside here.
Which is actually, we kind of already did this, didn't we? With the with the sort of a different shape. Yeah, this is crank. But yeah, this is just a kind of an idea that we did a couple of years ago. So there's a rotary encoder, and it's got a Neopixel ring, so I'm turning up the brightness on my computer. And then you could also plug this into our Pages project here.
So you can make like the fishing game everybody was commenting about. And yay!
There we go. That works with that too.
Yeah, so we'll release all these, I think, next week.
Yeah, I have the hinges already on Thingiverse if you guys want to check it out. I got a blog post up so folks can download it and try it out so they can
Crank it up.
crank it up. There you go.
Yeah.
All right, thanks, Noe Pedro. Exciting.
Oh,
Yeah.
All right, next up, Melissa, what are you up to?
Hi. Okay. I am up to working on adding boards like the Orange Pi R1 into Blinka so that we can run CircuitPython on these. The board I'm working on right now is the Odroid C2. I just added the Orange Pi R1 to a guide page, and that's already included now. So this one should be included soon. And so I'm working on going through and figuring out all the pins and everything that need to be done and the board definitions and everything. So
That's good because then people can use the libraries that we've written. It'll be fun, especially like I know people are always asking, hey, we want to use your OLED library on this random board. And I'm like, I have no idea what that is. And I don't know what pins are I2C, but now we'll have, we'll just do up all the different Linux boards that are out there. I mean, it's definitely an ecosystem now. There's dozens, if not, hundreds of different Linux boards or router or OpenWRT boards. So yeah, having people get access to Linux, but then also be able to use hardware is a plus. And you're going to guide them through it. Okay, well, people can check out circuitpython.org/Blinka to see boards as they pop in. Expect like one every week or
That's
two.
where we have everything. So circuitpython.org, there's a new link up top for Blinka. There's also circuitpython.org/downloads, and we have almost 60 boards. So we'll probably catch up with the single board computers with Blinka pretty soon. And also some news. Everybody welcome Melissa to Adafruit. Melissa is working with us full time.
Thank you.
In the chats and everything. Warm welcome. Thanks for all of your work helping in Discord, Melissa, and also all the goodies that people will be able to do with Linux, which is nearly impossible unless you do something like Blinka. So thank you.
Thanks.
All right, sweet. Next up, JP.
Hey, so real quick, I loved the speak and spell thing that Phil was talking about. And it reminded me of a quick related story, which was back in the late 90s, I worked for IBM, and I was in Atlanta, Georgia at a facility we had there. A team from their speech recognition division, wherever that was going around the country getting samples of people to broaden their abilities. And so I went in at one point and read words for a couple of hours. And then afterwards I was chatting with them and said, oh yeah, where are you from? I said, well, I grew up right outside of Poughkeepsie. Like, we did not need to travel to Atlanta, Georgia to get the voice sample of a guy from Poughkeepsie, because that's basically where IBM is headquartered. So
Yeah.
I threw off their Atlanta results a little bit with that, and I've always felt
But
that.
that's part of what in America, people are moving around constantly, so you're going to hear all sorts of accents from around the world.
It's all gone.
All right, well, you're now in the IBM synthesis
I'm in the
database.
I loved that thing, Phil. I think put that out because people want to play with that. I definitely want to play with that.
Okay.
So what I want to talk about is tomorrow on the show, on my live stream, I'm going to be showing this. Let me flip my camera over real quick to a Pygamer running a little demo of a Spy Hunter style game that I'm working on inside of Make Code. And right now it's just really a graphic demo. I've got, whoa, look out for that guy. I've got cars coming trying to kill me here, and I can move side to side, can't go past these roads, can accelerate and decelerate. And the cool thing, as I'll show tomorrow, is this is just kind of a simple demo, but it was also really quick to make, given some simple particle style or projectile style blocks that are available in Make Code. It was really quick to do something like this, where you've got things traveling at certain speeds, and then your controllable player here and having boundaries. Again, I continue to be amazed at what you can get done quickly in Make Code, and also the quality and the responsiveness of the end result. And it's really fun and satisfying.
Yeah, you can have a significant number of sprites on the screen, and yeah, I mean, like, it just works. It's so amazingly stable. I've been, writing some games in it, and you can't do everything, but the things you can do work very well.
Yeah, for sure. So that'll be on the show.
All the extras.
Tomorrow.
Things like the camera following the character, like it's so hard to do that. It's like it's it's so hard to do if you're doing it all in C or C++. So it's
Yeah,
such a,
and the concepts are kind of the important part. It's like teaching the logic and teaching the concepts of a tile map that represents the world, and then navigating around in that world and the layers of sprites on top of that. Like, this is all really, you know, still relevant to 2D games in particular, except you're approaching it from a really quick results based approach versus a C++ from the ground up type of approach. So I think
it's like, hi, I'm hitboxed. You know, it's just such a total pain. And like, you know, everybody basically has their own proprietary game system, and it's not a lot. It's open sourced.
Yeah.
So yeah, I think this is pretty sweet, and more is being added. I mean, like as we do projects and find bugs, I check out the forums. People who haven't yet, you can put in requests and they'll actually implement them. So now is this golden period where they're not overwhelmed yet and they're willing to add more capabilities.
Yeah, the best part about MakeCode, unlike MakeCode Arcade, unlike a lot of the other handle platforms that we're seeing coming out, is you can always learn from the games. You can always see how it's made, which is more fun than just playing a video game. So.
I think so.
Yep.
All right, thanks, JP. Okay, Brian. L and U's. U's and L's.
Yes, can you hear me?
Yes.
Okay, so I've been making UNLs. You might ask, what is a UNL? Well, it's a U and an L all together so that you can attach your Neopixels together in L's or U shapes. So in doing so, I had to figure out how to get the ends of the different types of Neopixel strips to attach correctly to the circuit board so that we can make all these fun shapes. And in doing so, I learned something interesting. That is that there is no less than 3 different sizes of Neopixel strips. They each need their own footprint. So that was fun. So let me see if I can switch over and show an example of what I've been working on. I think that does work. Can you guys see that now?
Yeah.
So this is a
Use.
Yep, this is an L and U. So we got some L's down here, 2 different kinds that I'll get back to in a second. And this is a U, so you can imagine your chip coming in here and going out there, or coming in here and going out there. The L is similar; it will come in here and go out there. Actually, that's this kind. So this is like I call it like a simple L. So the strip will attach here, and a strip will attach here, and it'll make a nice L, but there won't be any Neopixel right here. This is, I don't have a name for it, but what it will do is you'll attach here and the strip will go down this way or up, depending on your perspective. And then another one will go this way so that there will be a Neopixel here, basically so that there will be a Neopixel right in the corner. And you won't have that one missing one in the corner. So this is just like a little kind of mini panel thing. It's got mouse bites so you can separate them. And we'll be making these in different sizes for all the different types of Neopixels, you know, PCB sizes and number of pixels per meter. So
U's and L's. U's and
L's. Yes.
Okay, thanks for the update, Brian. It's a sneak peek. Coming soon. All right, next up, let's go to Zen. Hey, Zen, welcome.
Can you hear me?
Yes, we can hear you now.
Oh, okay. So I go to Goodwill and look at different stuff, and I happened to come across a Hula Bra and decided I would make a Hula Bra with Neopixels and the Gemma M0, and so basically it's a so that I can show what it looks more like.
Oh, yeah, it looks purple and green, different effects.
With the Gemma, I had an extra thing left over, so I used the capacitive touch to be able to change then what the Neopixels are doing.
You're so set for summer. I mean, then you're going to go, you got your beach body ready.
Yeah, exactly. And I live in Asheville, and there's a lot of costuming and stuff like that going on. And so I don't know if you can see.
No, yeah, sparkle effect. I love it. This is
I like
great in the parades.
The smiley is the big favorite.
Yeah.
And same with the twirly, which you can get, going like this.
Yeah.
or whatever. It was just a weekend project because I ordered a bunch of Gemma M0s and thought I really want to do this. It also has capacitive touch on each side. It's just a wire going between them, and with the LiPo 500, it lasts about 12 hours. So a full party night, and so you can get good and drunk. And
well, what's good is that when you go to a party where everyone's got a Hula Bra on, if you lose yours, you'll know. Just don't jump into the pool with it, okay? The only thing that's missing is a Scene on the Show and Tell sticker. Email support at adafruit.com. Put it on the side, and everyone will know.
Right there you go.
Show and tell.
And, so I just have it do a bunch of different, which is fun to sort of come up with different routines that it goes through. But that's all it does, and I've already got people wanting to buy one. So
great for mitzvahs, weddings, funerals.
Next I should do the skirt, which then would have Neopixels go down, or the little the littler ones, the twinklers or whatever. Yeah. That would be fun. So
can't wait to see it. Come by. Check that out. All right, next up, Orlando. Do you have a Hula Bra you want to show off?
I do not know bra.
It is a shame when you show up at the same time.
What do you have to, Orlando?
Oh, well, it's good to be back after such a long time.
I know. It's summertime.
Now we have time for fun things. But I've been working on what I call the ISO bunny. So you use an opto isolator. So the opto isolator, essentially, you're able to separate signals that may be contained to something high voltage with something that's low voltage, like a motor versus an Arduino. That way you can essentially protect the low voltage device. Specifically, this one is for bioelectric signals, so like cardio, electrocardiogram and things like that. And so the reason for that is, whenever you're doing any sort of things with electrocardiogram where you basically hook up your electrodes to your chest to measure your ECG, you don't want to connect yourself to anything that might be high voltage, because if there's any sort of short or anything like that, that can be very disastrous for you. So the ISO bunny essentially, so I had this with the students projects, but essentially they were building their own ECG. So they connected, their ECG to the analog side, and then they were able to safely connect to the other side that's doing all the sensing and things like that. That's connected to benchtop power supplies, LabVIEW, et cetera, et cetera. So it's fairly straightforward. So the way these guys work, they use essentially just an LED and photodiode on the inside. So essentially coupling the signal via light. So if there's any short in between, all it does, it just burns the light out, which is no big deal. So it's a cool little knick-knack that I made for the students. They didn't necessarily quite appreciate it as much as I did because they're introductory circuit students.
Well, they're happy. It's good to introduce safety to them early. I mean, it's not something you want to design last. You have to design in early. So even if they didn't know that they appreciated it, you can show them stories of before we had opto isolation and the things that could happen to you. And that's not fun at all.
Hopefully, the 6 of them they're remembered for later. But it's a little isolation module.
Well, nice work.
Filed up on GitHub. I don't know what I'll do with it after that, but we'll see.
Yeah, post it up. I'm sure people are always asking for isolation modules. It's always handy, especially one that works with an ECG because of the analog levels.
Okay.
All right, well, good to see you again.
Yeah, if you want to stick, get a hold of us.
Yeah.
Be back.
JMK, what are you up to?
Hello, can you hear me?
Yeah.
Okay, so my mom had this old Garmin GPS in her car, and she didn't need it because she's using her phone or her car GPS now. So I thought, why don't I hack it? So I realized that Garmin has a lot of open source software. So I'm going to share my screen. So this is all their open source software, but the one problem is they don't have it for my specific one. I have the 2455, and then we started using it in the 25XX. So so I was like, come on, because I couldn't build it and run a custom version, which I would have done. So I decided, oops, stop sharing. to hack it myself. So I looked into the help. So I plugged in the device to my computer, and I looked at the help files for the Garmin help directory or whatever, the help section, and I realized that they were just HTML4 files. So I was like, now I know what to do. So I just I tried all sorts of tags. It's only HTML4, but it's good enough. And so I coded this. It's called Nuvi Hacks because that's the name of the Garmin.
Cool.
And, it's got. So I'm coding an app to inject custom HTML into it. Trying to make like a setup app and it has no internet, but I'm trying to make it so it can load it in from a computer. And I decided, if I'm gonna go on Adafruit, why don't I put the Adafruit logo on it? So I was testing the image tag, and I thought, well, of course I'm gonna use the Adafruit logo.
Yay!
So I got the Adafruit logo on the Garmin, and I wanted to get it animated, but when I try to GIF, it just says image not found. But whatever. So yeah, that's
all right. Good work.
And I'm gonna try to see what other tags I can use, and maybe I can get some sort of like animation or interactive element or whatever to work on here, because obviously they're not using like Chrome on a GPS, but they've got some sort of HTML viewing thing that's good enough to view images and this and that, and has a scroll bar and a search and stuff. So yeah, I also tried to load the Adafruit website, a whole website. I just copied everything and put it on, and well, it doesn't work, but you've got a few text things there, and I'm gonna try to work that out too. So yeah.
All right, Friday. There's a mini Wikipedia for projects like this. I know that they made a miniature version of Wikipedia. That'd be cool. So maybe try that. Come by next week. We'd love to check it out.
Great, thanks.
Thanks, NK. We'll send you a sticker if you need one.
Yeah, if you want a sticker, just have your folks drop us an email. Okay, that's the show and tell.
Thank you, everybody.
Tonight. Thank you, everybody. Thank you,
Zen, Scott, Phil, Dragon, Orlando, Noe, Pedro, Melissa, JP, JMKM, Brian.
We're here every single week, 7:30 p.m. Eastern Standard Time. Thanks for making this the best half an hour of our week every single week. We'll see everybody on Ask an Engineer, which just starts in about a minute or so.
Happy summer, everybody.
Okay, bye-bye.
Later.